Okay, so related rates are used when we're working with variables that are related in some way. Okay, and I guess it really derives itself from the use of our chain rule. So we consider the chain rule where dy dx is given by dy du du dx. So the variable u relates to two variables y and x in some way. Typically for us, we talk about volume. The volume of a liquid in a cone or a cylinder might depend upon the height of the liquid in the cone or the radius of the liquid at any point in time. So our related rates, combine multiple variables together to come up with one difference or differential equation. All right. I guess one thing to really note in terms of trying to identify what quantity we have represented, centimeters cubed, volume, isn't it? It's a three-dimensional centimeters squared, typically in area. Centimeters, a linear representation. So that gives us an idea of the quantity that we're sort of measuring or the quantity that we've been given. Obviously, if we've got a negative value, my quantity is decreasing in amount. If we have a positive value, it's increasing. All right. So a typical example. So let's consider our water tank, shape of a cylinder. The radius is equal to half the height. Right. So the tank is being filled rate of 4 meters cubed per hour. Find the rate at which the height is increasing after 90 minutes. So a couple of things in here. The rate of increase is 4 meters cubed per hour. Volume per time. So you see in here, dV dt is equal to 4. All right. Now, because we have a cylindrical tank, we know the volume of this tank is pi r squared h. And we also know that the rate is equal to half the height. So if we look at our volume of our cylinder, we've got radius and height, both variables. So we need to be able to find a relationship between two of those variables. And in this case, it was given to us quite specifically. So if we substitute that in, we get a volume is in fact a quarter pi h cubed, which means now if I differentiate that volume with respect to height, dV dh is pi h squared. From my chain rule, dV dt is equal to dV dh, dh dt. So dV dh I've just worked out, there's my 3/4 pi h squared. My dV dt was given, and we were asked to find the rate of the height was increasing, so dh dt. So now I've got dh dt is equal to 3 pi, whatever it is, 16 over 3 pi h squared. Okay, so we've got my dh dt there. Now we're interested in the rate the height is increasing after 90 minutes. So we've got t, but at the moment my derivative is in terms of h. So I now need to apply my integration techniques. So I've got dh dt equals, so it means dt dh is equal to the reciprocal. So if I integrate both sides with respect to h now, add 1 to the power, divide by 3, and so we end up with t is equal to pi h cubed on 16. And it said that initially the tank was empty, so at t equal to 0, h is equal to 0, which means c will be equal to 0. All right, so now I know that h cube is equal to 16t on pi, which means h is equal to the cube root of 16t on pi. All right, so now I've got h in terms of t. Since we're interested in the rate of height increasing to dh dt in terms of t, we can differentiate that. Look, we obviously can go through that process on manually, but I think it's involved enough to suggest that maybe we'd have access to CAS. So if we've got our h equals, we've got our h equals over here, obviously differentiate and evaluate at t equal to 3 on 2, and in exact form, we get that expression there, okay? So look, I'm not convinced that the question's written the way it was meant to be. Very rarely do you see us having, I guess, ending up with an equation in terms of h and then rearranging it and have to differentiate again. But, if that's the way it is, that's the way it is. All right, off we go.